Welcome everybody. Welcome to this webinar session about inference training with Retrieval Augmented Generation. Today we will make a demonstration about how to implement Retrieval Augmented Generation to improve LLM responses in HPC environments. But first I want to start with a brief introduction about our project and what we are doing. EXA4MIND is a funded by European Union Horizon program, and the goal of this project is developing a platform for extreme data to enable advanced data analytics on supercomputers. And as a METU team, we are working on advanced querying and analytics to allow querying across different database systems like SQL database and NoSQL databases. And within the scope of this project, we published an article in Natural Language Processing journal very recently. And in this paper, we introduced a cross-domain text-to MongoDB dataset by utilizing Spider, text-to-SQL Spider dataset. And we leveraged LLMs to generate SQL equivalent MongoDB queries for each question, natural language question. And this dataset is available on Hugging Face in this repository. And I want to also very briefly mention when we need HPC environment instead of local environment. If you are working on highly demanding tasks like large-scale simulations, scientific computing, or big data analytics, then HPC is the right choice. Also, you can split tasks and perform distributed training across multiple nodes in HPC environment to increase speed and scalability of your program. And HPC systems has some dedicated job schedulers like Slurm systems to manage resources and queue the incoming jobs to the available nodes. And HPC systems has a dedicated file system to transfer large-scale data from local to HPC nodes. And if you are working on, as I said, large-scale tasks like training very large models or running large simulations, then HPC is preferable than the local systems. And I want to very briefly show our technology stack for our inference module. This is a screenshot from our inference system. We have an user interface, and users can also send their requests using the API calls. It's a REST API-based inference system, and we are using Fast API in Python. And for the user interface, we are using Streamlit, and for data validation, Pydantic. And in order to integrate our inference system to HPC environment, we are in collaboration with, we have a collaboration with IT4I from Czechia, and we are using their own middleware solution, HIPI, to send inference request as a job and run the user requests as a job for a dedicated time period. We are using HIPI, and HIPI allocates resources and perform the tasks and return the results for us. And we have a message queue. We are using 0MQ for this, and we use 0MQ for both communication between the models and the Fast API, but also 0MQ also schedules. We are using it for load balancing, scheduling the incoming request to the available GPUs. And also, we are both developing our own inference engine, but additionally, we want to support some end-to-end inference solutions like NVIDIA Triton. This is also one of the objectives of this project. And finally, users can use any AI model from the following LLM repositories like Ollama, Hugging Face, and VLLM. And in this training session, we will show how to implement RAG in your own local system to improve LLM responses. And here I want to show the pipeline. First, we need to divide our knowledge base into chunks, document chunks, and we need to use an embedding model to embed, extract embeddings and store them in a vector database. Then at the runtime, when a user writes a prompt, the embedding model encodes this user query, translate them to convert them to a query vector, and then we retrieve the semantically most similar k chunks from the vector database, and we enrich our user prompt with this retrieved context. And our aim is to improve the LLM response. And in this example, a user asks, a student asks when incomplete grades will be announced, and without RAG, LLM response said it has no information about this question, but when we retrieve the relevant context from the university's knowledge base, LLM generates a more accurate response, and we improved the LLM response with this approach. So RAGs can be used to retrieve semantically similar contexts, but they might not perform well on exact matches. If you want to retrieve exact matches for some error codes or specific model, etc., specific error code or some specific model, for instance, you can use some additional approaches like BM25 retrieval or additional retrieval approaches to retrieve exactly context instead of semantically similar context. And in this demo, our demo consists of 4 steps. And first, we prepare our data set, then embed our documents in a vector space, and then we perform semantic similarity search using RAG. And we show that the LLM responses are improved with this approach. And now Görkem will show the demo and perform training. Thanks for your attention.
So, hello everyone. My name is Görkem Özer. I'm a PhD candidate in Middle East Technical University. So I'm going to talk about the Retrieval Augmented Generation demo that Fırat mentioned. So we will go over this Jupyter Notebook file to illustrate the benefits of Retrieval Augmented Generation. So first, we need to create our conda environment with conda create-n, our environment name, and with Python version 3.12.0. So after this, you need to activate your environment again by doing activate environment name that you have chosen. So for this demo, for this webinar, I have chosen EXA4MIND webinar environment. And what we should do then, I'm using Visual Studio Code, and if I open this Jupyter Notebook, so we need to select the environment for that. So I'm choosing this environment, and then I'm starting to install the required libraries. And at the moment, you need to do the installation again. So while it is installing, let me mention the requirements. So IPython and pandas, these are all usual things. And a PDF miner library is for converting the PDF documents from to the textual documents, so that we can use these texts to find the similarities between the prompt and the existing text. SQLite Vector Rec is the VectorDB library for the SQLite database. So for the demo purposes, we use SQLite for the database, but there are other vector databases as well, such as there is an extension for PostgreSQL. There is MilVuSDB, which is purely VectorDB. And FastEmbed library is for finding the embeddings, creating the embeddings, and yeah, it is mostly about that. So our libraries are installed. So let me briefly mention what we are dealing with. So I have downloaded this academic rules and regulations regulations from the Middle East Technical University, and what we are converting to text is basically these articles. And previously I have downloaded them as PDF, and I will share those PDFs with you in the examples, and you can find them in the docs folder. Then we will convert these to text, and we will try to find out the similar content, similar articles from our prompt. So we have installed the libraries. So let's import them. And so defining the constants. The constants are basically for the folders and the SQLite DB name. So once we do this and start the PDF to text task, for each document, we will have our text. So from those PDFs, we have our articles converted to text. Notice that for our eyes, we are human and we easily understand that these are the articles. But for your own retrieval augmented generation case, it might be something different. Maybe it is meaningful to have this as a block and then take the embedding of it. But maybe it will be better for you, for instance, take each sentence as a block. Maybe, yeah, for instance, here there's a sentence. So maybe this is what you should use embedding and compare against the prompt. Well, that depends on your case. But for our case, let me show you. So we are considering all the text split it by 2 new line characters. So which is basically if our text has 1, 2 new line characters, then we consider this block as a single unit, and we take the embedding of it. Then let's continue. So this section, adding metadata table to the database, is basically generating IDs and textual information. So which is most likely the articles, but there are, for instance, scope, basis. These are also the separate things because of our rule. And as I said, that could depend on how you choose your strategy. But at the moment, I'm doing that. It shouldn't be an empty string. The length of the sentences should be more than 1. It should contain dots, etc., etc. And I say I'm splitting by 2 new line characters. So these paragraphs and their text is included in our database. So once we do that, we have processed our documents. Now we need to create the embeddings. So there are 2 ways of doing this. You can do the embeddings and do an in-memory similarity check. Or in this case, we are doing in database because we have a lot of articles and we don't want to recompute embeddings all the time. So we need to store the embeddings in the database again by doing this. Sorry. So we need to create the model first, and we need to insert the document embeddings to the database. And let's see, while they are being inserted. So let me talk you about the sample questions. So I have, for this demo purposes, I have created 5 sentences, but you can define your own sentences. And we will see that the answer to these questions changes depending on the content that we are adding. So let's go with the question, for instance, question number 3. So let's select this question 3. And there is so user prompt is the question itself. And there is the enriched prompt, which will be the prompt variable. So let me summarize that. So we are basically retrieving all the top five most similar articles, and then we are appending them under the original question. So this is the original question, and these are the retrieved content, which are very similar to what we have asked here. And for the inference purposes, so let's look at that. And this function is basically calling the API endpoint that we have developed in terms of or in the scope of EXA4MIND project. So currently we have deployed it on our local server here, and we call the inference endpoint like this. But this inference endpoint can be called with different models as well. But for the demo purposes, we are just sticking with the one model because it will take time to load the model to the GPU. So for the moment, let's try first without enrichment. Let's check what the model responds. So this is the large language model is 20.5 coder. So let's see what it responds to us with this within the same point. So it returns something, and let's see the enrich prompt. So as you can see, it is talking about specific things instead of answering that without a context. So sometimes the LLMs may already be trained by the data that you are already using. But in any case, by providing a retrieved content, you are actually guiding the model to generate some response. So this is the raw prompt, and it is giving us some information about generic information that it has already embedded inside the model. But if we use the enriched model here, enriched prompt here, for instance, then the answers will be quite specific to that thing. For instance, here they're talking about, for instance, proficiency in English. They're talking about different programs. And they're talking about EPE, which is the specific name that is used for English proficiency exam in Middle East Technical University. So with enriched prompt, you are getting the targeted generation, and you will most likely have a better generation. So this is the case of using the API. So if we were to continue with the user interface, we can do something like this. So let me continue with that. We have seen the Retrieval Augmented Generation through the API usage, but you can do the same with the enrich prompt. Let's say you have generated your enrich prompt like this by using some similar structure. So what you can do the same thing for like this. So let's say we would have EXA4MIND platform for inference soon. So let's say what you should do, you should just go paste your prompt here, and you'll be able to see the content again. And I think you can't see the screen. One moment. I should share my screen again. So whole screen. Okay. So now you are able to see that. Okay, fine. So Let me repeat that. So we have seen the Retrieval Augmented Generation through the API in the code. So this is the generated prompt you have. So let's say, yeah, you can choose any other vector DB. You can choose any other method for identifying the embeddings or documents, etc. Let's say you have this enriched prompt at the end. So what you should do, you should copy paste the prompt here. This EXA4MIND inference platform will be published soon. And once you generate the text with that, you should be able to see the model response. So just like what we have retrieved in the Jupyter notebook, same also can be retrieved from here. So maybe we should test it again. So let's choose another question. Maybe let's go with the first one. So I have my user prompt. I have my enriched prompt again. So this is what you will likely need to do. So let's remove this, paste it again. So this is the new question, and this is the new information. As you can see, for incomplete, it is something else. It has different rules. Let's generate that again. So will typically be announced within a week from the last day of grade submission. So this is the case for our university. So the model responded based on that. But if we haven't provided that information, it would respond with some other answer. And it's not guaranteed that the model will answer to satisfy your question. As you can see, it is just talking about a generic response. And yeah, these are all the things that I can explain about the Retrieval Augmented Generation. I hope that you can follow the Jupyter notebook that we have shared and do your own experiments in EXA4MIND inference platform soon. And thank you for listening.